rules. Here's how you simplify these expressions. So that's what we'll do most of this week. But then after that, we're going to take a couple of days to review percentages and proportions from 7th grade, because percentages are really super duper important. And then we're going to get into exponential growth and decay. And it's one of my favorite things to teach because it is pretty cool how it works out, and there's a lot of things in real life that you can use it for, particularly things like calculating interest on bank accounts and exponential growth of populations, that sort of stuff. There's a lot of science applications from it. There's a lot of cool stuff. But for the next 4 days, we're not applying anything. We're just learning these rules and learning how to simplify these expressions, right? Which also means no word problems. So those of you that hate word problems, this will be good for you. Exponents really mean repeated multiplication. Okay, so for example, when we see 2 to the 5th power, it means 2 times 2 times 2 times 2 times 2. Okay, so if we want to calculate 2 to the 5th power, we're going to have to multiply 2 5 times. All right, so if we're figuring that out, we'd have 4 times 4 times 2, that would be 16 times 2, so we would end up with 32 for that. Okay, it's really important that you understand that that's what's happening. It's that value being multiplied, because I cannot tell you how many times that I see students do this right here. Like almost every problem, at least one student gets it wrong. And given some of your track records with negatives and messing up simple multiplication, we got to really be careful with this. Okay, so 2 to the 5th would not be 10. 2 to the 5th is 32. All right, so we got to be careful with those. So these all have just numbers. You don't have any variables for 1 through 10. So I want you to take a minute and calculate the values for these. By hand, I don't want you using a calculator on these.
Numbers or just like
I want the numbers.
that? All right.
Right. So final number answers for this. it means that negative is also multiplied. These right here, this would not be negative 3 times negative 3 times 3. You actually have the same answer, but it would be negative and then 2 times 3 times 3. Unless there's parentheses, only the number is squared, not the negative. You gotta do negative 5 times negative 5 times negative 5. I didn't explain that to you this morning. We didn't get that far. All right. Check with your neighbor and see if you're getting the same answers as them. See what they've got. So like for this part, you have to do negative 4 times negative 4 times negative 4. And then since these two are right next to each other with nothing in between, it's multiplied by negative 2 times negative 2 times negative 3. Neither one of you are right. Whenever you have parentheses that are right next to each other, what you do is multiply. But you don't multiply the bases that way. You need to get you need to do what you did. You need to get 9 times 8 9 times 8 is 7. I'm going to say. Okay. I'm going to put the answers up here. All right. 1 is 125. 2 is 81. 3 is negative 8. 4 is negative 64. 5 is negative 125. 6 is 72. 7 is 243. 8 is 512. 9 is negative 160. And 10 is 8 over 27. A couple things I want to note, because you might have actually gotten the right answer the wrong way on number 3 and 4. I should have done one with an even exponent. A couple of you asked me about this. What's the difference between number 5, where we've got this in the parentheses, or number 3 and 4, where the negative is not inside of the parentheses? There's a big difference. It ended up not mattering because there was an odd exponent. But when you see the negative 5 is raised to the third power, it means negative 5 times negative 5 times negative 5. When you see negative 2 raised to the third power, only the 2 is raised to the third power. So the negative just kind of hangs out front here. And then you got 2 times 2 times 2. So it's not all 3 of them that have negatives. It ends up giving you the same answer either way. But would it give me the same answer? Did these two give me the same answer? Let me put a couple up here. What about if I have negative 2 to the fourth power versus negative 2 to the fourth power? Okay, if I have negative 2 to the fourth power, the negative is not squared, or not raised to the fourth power. It's just out there. And then the 2 is raised to the fourth power, so I've got 4 2's. So that's going to give me negative 4 times 4, which will give me negative 16. So it keeps that negative. But what about over here when I do negative 2 times negative 2 times negative 2 times negative 2? All right. Negative 2 times negative 2 gives me positive 4. And right here I also get a positive 4, which is going to give me a positive 16. So if the negative is on the inside of the parentheses, then it is also being raised to that power. But if it's not, if it's just hanging out front here, then it's just written one time. Pretty good. Maggie Tomlin. Okay. Questions on anything there? Which ones are confusing you a little bit? What do you think? For 10, since it is 2/3 to the third power, it's going to be 2/3 times 2/3 times 2/3. And when we multiply fractions, we just multiply the numerators and then multiply the denominators together. So this 2 times 2 times 2 is going to give us the 8 in the top. And then 3 times 3 times 3 will give us that 27 in the bottom. If you want to think about this, there's also another way you could do it, really. We could also do it this way, 2 to the third power and 3 to the third power. We could raise the top and the bottom of that fraction to the third power, which will also give you 8 over 27. Okay, which other ones do you guys have a question about? All right, so this is all stuff with numbers. You start doing this in like 6th grade. You deal with exponent, maybe even 5th a little bit. So these are problems that I don't know if they've done a lot of negative stuff yet, but definitely the ones without the negatives, I should be able to give to Hunter and he should be able to do them. That would be a good experiment. I might need to try that to see if he actually can. But you deal with exponents with numbers earlier on. What we're going to do that I believe is this should be the first thing we're going to do that is completely new. You have not done any of this in 8th grade. Maybe systems like substitution, elimination. I don't think you did any of that in 8th grade, did you? You may have graphed a couple together just to see, depending on if Miss Ball kind of worked ahead. But definitely exponent rules is going to be one of the first things we've not done this before at all. There are 3 different properties that we are going to need to know today. The first is for whenever we're multiplying with the same base. So I've got x to the second times x to the fourth. So I want you to get to where you don't have to write this out every time. But the first time, I want us to write out what this means. So x squared means x times x, right? And then x to the fourth means x times x times x times x, right? So how many x's do I have that are multiplied together there? I've got 6, right? So this is going to equal x to the 6th power. So that's a pain, especially if I've got bigger exponents to do every time. What shortcut could we use? Add those exponents, right? So add the exponents. Now that rule alone, students usually do great with. But now I'm going to throw 2 more rules in there, and that's when students start getting mixed up because they use the wrong rule for the wrong part. So let's think about what this means. X squared to the 5th power. That means x squared times x squared times x squared times x squared times x squared. And each one of those x squareds means x times x, right? So this one would be x times x, x times x, x times x, x times x, and x times x, right? How many x's have I got multiplied together there? I've got 10. So I could write this as x to the 10th power, right here. Okay? But that's an even bigger pain than what I did on the first one. So what shortcut could I use there? Isabella? I can multiply those exponents together, right? So now, this is only used when you're raising a power to a power. So I have something with an exponent, and I'm raising it to the power again, right? That's when I'm going to use the multiplying. Whenever I have 2 bases that are the same, and I'm multiplying those things together, I add. You can see how it kind of gets like a little bit easy to get those rules mixed up. All right, now Isabella doesn't know the answer to this because we didn't look at this morning. Quotients of powers. Quotients means to divide. What do you think? All right, what do we do? Okay, so I got 4 x's on the top and just over a single x, right? What is something divided by itself? It's just 1, right? So like if I take this x right here and divide it by this x in the bottom, x divided by x is just 1, right? So these cancel each other out, which means that I would have just 3 x's left in the top, right? So I got x to the 3rd. In the bottom, I don't have anything left. What do I put there? Not a 0, a 1. Or what is anything divided by 1? It's just x to the 3rd. That matters if you have leftovers in the bottom of the fraction. So in the if we had like 1 over x to the 3rd, we would have to have that 1 in the numerator. For the denominator, it doesn't really matter whether or not you write this 1 right here for this problem. What shortcut could we use there? This one's a little less obvious. Okay, I'm subtracting because what exponent did this x right here have? It had 1, right? So subtract exponents and put your answer on the side with the most x's. Yeah, like if I had x to the 4th over x to the 6th. If you do top minus bottom, you'll get negative, and we'll talk about that because we are going to do a section on negative exponents, but we're not going to do it today. So everything today, you should not get any negative exponents. So I'm just going to do 6 minus 4, which will give me 2. But where do I have the most x's at? On the bottom. So the leftover x's, like if I write it out, they're going to be on the bottom. So it's going to be x squared on the bottom. And when you have something like that on the bottom, it's important. You have to put the 1 on top. Putting a 1 on the bottom is not required because x to the 3rd divided by 1 is x to the 3rd. But if the leftover x's are on the bottom, you have to have that 1 on top. Okay, so let's do some examples with these. For number 11, raise your hand if you think you know what that one is going to be. All right, Lanaya. Perfect. A to the 12th. Something in me wants to do 35 right there. 5 times 7 is 35. But when you're multiplying like bases, you add the exponents. All right? Okay? Who can help me with 12? All right, Savannah. B to the 35th. We're doing 27 plus 3 plus 5. There. Okay. All right. Okay. 13's different. Who can help me on that one? All right. Aiden, what have you got? X to the 30th. Very good. We multiply those exponents together. Okay, now let's look at number 14. 14 is going to be different because 14 has this 3 right here. Does anybody know the fancy name that we call the number in front of a variable? What is it? Coefficient. So this is the coefficient. So sometimes those call them the big numbers, right? They're not the little numbers. Those are your exponents. They're the big numbers, right? So this number right here is called a coefficient. Okay? Coefficients do not follow the same rules as the exponents. So you have to be careful with that. What we want to do with the coefficient here is, let me do this actually. Okay. So what we want to do with the coefficient is the coefficient is raised to the first power. Okay? It's not written there, but that's 3 to the first power times x to the second power. So we are going to raise this, both the 3 and the x squared to the 4th power. So that is going to be 3 to the 4th power, and then x squared to the 4th power. When I do, I'm going to write this down, but you don't have to. I would usually skip writing this step right here. What is x squared to the 4th power going to be? X to the 8th. So I've got 3 to the 4th, x to the 8th. And unless you get an exponent bigger than, let's say, 5. If you get an exponent bigger than 5, so 6 or above, I'll let you leave exponents. But because the numbers get pretty big. All right. So if I multiply that together, I get 9 times 9, which is 81. So I get 81 x to the 8th power. So the 3 is getting raised to the fourth power, and this is also getting raised to the fourth power. It's really common for me to see students do like 12 times x to the 8th power. They multiply that, but you're doing 3 to the fourth power, not 3 times 4. There. All right, what do you guys think on this one? There's actually a couple different ways you can do this. So, all right, so give me one of those ways.
So subtract the x5 from the x2, obviously, so it will be with x3.
Okay.
And then you multiply it by the x7.
Raise it to the fourth power is the way we'll save that. And we also don't want to call it like x5 and x2. We want to call it x to the fifth and x. Well, what's the special name for x to the second power? Squared, and to the third power cubed. But then after that, there's not special names, so we would say x to the fifth divided by x squared. There. This looks great. Raised to the fourth power. What's that going to give you, Evan? Okay. X raised to the 12th. Good. All right. So, so that's one way to do the problem. There's another way to do the problem. Who else could tell me a different way I could do that same problem? What do you think, Aiden? Okay. So that'll give me x to the 20th on top and x to the 8th on bottom. Then what would I do? Subtract. And that also gives me 12. Right? So what you're going to see on a lot of these problems is that as long as you follow the rules, it doesn't matter which way you do the problem. Now, there are things you can do that will break the rules. Like, for example, if you did something like 4x to the fifth over 4x squared. Like, you multiplied that by 4 instead of just multiplying exponents. Like, there's things you can do to get these wrong. But the order that you do them in sometimes doesn't matter. Okay? Oh my, 16. They're really throwing a wrench in here. Alright. Alright, what do you think? Uh-huh. Perfect. That's all you're doing. You're still just multiplying those exponents together. 3n times 5 is 15n. So even when they throw variables in there, you're still just following those rules, right? If you have a power to a power, you multiply those exponents. All right, Caitlin, what do you think for number 17? All right, so we're raising this to a power. When we do a power to a power, what do we have to do? Multiply. So a to the 21st will be on top. What will we get on the bottom? B to the 9th. Can I put this together? I cannot because they're different letters. So I just have to leave it like that. Okay? Kaylee, what do you think for number 18? Perfect. So what's that going to give us? Okay. A to the 16th power and B to the 20th power. Can we put those together? No, different letters, so you got to keep them separate. All right. Any questions so far? All right. 19. You know how to do it, Isabella? Okay, I don't think it'll take you too long, maybe. All right, what do you think? Okay. All right, what do you think, Savannah? Sure. Not quite. What do you think, Evan?
I believe the answer is 58 to the second power with b to the 8th power.
Nope, not it either. Anybody else want to take a shot? What do you think, Aiden? Nope. Nope. Alright, so when I have all this stuff together, it's all multiplied. When I have those parentheses right next to each other, it's multiplied, right? And then all of this is multiplied because it's all right next to each other. Okay? Another important thing to remember is variables that don't have exponents, what are their exponents? 1. So this a right here has a 1, and this b right here has a 1. So if you have a variable without an exponent, it might be a good idea to put a little 1 right there so you remember that it does have an exponent. So, I could reorder this if I wanted to because everything's multiplied together. I could write it like this. 2 times 5 times 6 times a to the first, a to the second, b to the third, b to the first, b to the fourth. Right? What is 2 times 5 times 6? 60. Right there. Then how many A's do I have? 3. And how many B's? Nope. I've got 8. Because this B right here doesn't have exponent written, but there's 1 of them. So if there's no exponent written, you want to add that 1. So what we can do here is you can multiply all your coefficients together, 2 times 5 times 6, and then you're just looking for your variables that are the same. You're putting that together. You don't have to write it where you've reordered it right here. If you skip that step, that's fine. But make sure you don't forget those variables that are just to the first power. It's easy to forget them. So it may be a good idea on a problem like number 20, as soon as I look at this, I see an n right here and it doesn't have an exponent. So what is its exponent? I'm going to put a 1 right here. What about on the bottom? I also have another n that has a 1 for its exponent. Okay? So, I'm going to hold off on those coefficients for a second. They might give me some trouble. I've got m's. I've got m to the 30 on top and m to the 12th on bottom. What should I do with those exponents? Subtract. How many? What will I get? 30 minus 12 will give me 18. Should I put it on top or bottom? Top, because there's the most m's there, so the leftover m's are going to be on top. What about the n to the first and the n to the first? If I subtract, 1 minus 1 gives me 0. These are going to cancel each other out. So you won't have an n at all. Okay? P to the 15th, P to the 10th. I'm going to subtract those. I'll get 5. Anya, should I put that on the top or the bottom? Top. So P to the 5th, because there's more P's on top, right? So the leftovers are going to end up on top. All right, so that deals with our variables. I kind of just ignored the negative 4/6. Okay? What you want to do with these coefficients right here is you just want to reduce them if possible. Right? Negative 4/6, can we reduce that? We could. It would be negative 2/3, so we'll put a negative 2 up here and a 3 on bottom. And there's nothing else you can put together there. Yes. You can write it a couple different ways. You can write it like this, or you could write it like this, negative 2/3 times m to the 18th, p to the 5th. Either one would be okay there. questions on that one? All right, let's keep going. They're getting more complicated. Oh. 21. What are we going to do? There's two possible first steps. Or you could do them both at the same time, really. What are you guys thinking? What are you thinking for a first step on that one? All right, deal with that second fraction first. Okay, I like that because order of operations tell me I got to do exponents before I can multiply, right? So I cannot put these two together and then raise it to the second power. That square only goes with the second one. So that's going to give me x squared y to the third over 4xy times x to the fourth over, what goes in the bottom? That y right there has a 1 for its exponent. It's going to be y squared, right? Or to the second power. It's either one of those is okay. Okay, because we're multiplying the exponents for both of those. Here's where you got a couple options on what you do next. So somebody tell me something they want to do next here. Any ideas? We can. So this is multiplied together. To multiply fractions, we just multiply straight across, right? So that would give us x to the sixth, y to the third, over, what would we get on the bottom, Isabella? How many y's do you have on the bottom? 3. You got 1 here and 2 over here, so I'll give you 3 altogether. Okay, I like that, but we're not done because I still have more than one x and more than one y, and I can combine those here. So now if I've done this, what should I do? Very good. So I'm going to do, this x right here has 1 with it, so 6 minus 1 gives me 5. Should I put those x's on the top or the bottom? Top. So I got x to the 5th. And so that takes care of my x's. What about those y's? They cancel because they're the same on top and bottom. And the coefficient, you can't do anything with it. It's just going to stay where it's at. So we just get x to the 5th over 4. Okay. Just got a few more to go before I give you guys your assignment to work on. I've got negative c to the third times negative 2a squared bc times 3a squared b. So I'm going to go through here. I'm going to make that b to the first power. I'm going to make this c to the first power. I'm going to make that b right there to the first power so I don't forget the exponents for those. I'm also going to do this. This negative right here, what is that really? A negative 1, right? So if I multiply all of my coefficients together, negative 1 times negative 2 times 3, that is going to give me negative 1 times negative 2 is positive 2. Positive 2 times 3 is 6. And I'm going to make sure I'm only putting together the like terms. So how many a's do I have? Negative 1 times negative 2 will give you a positive 2, and then multiply that by 3 will give you a 6. Got 4 A's. How many B's? Got 2. How many C's? Sure about that? 4. Okay? Yeah, I'm good. Giving you guys a second. Alright, questions so far? Alright, 23. So 3 variables in here on us. Extra variables. What do I need to do with my exponents here? I'm going to add them. Because I don't have a power to a power. So, like, when I have x squared to the third, that's when I multiply. When I've got a power raised up to a power. So that would be, x to the 6th. If I have x squared times x to the third, that's when I add. That's when I get x to the 5th. Perfect. Yeah. So they kind of do the same thing for you here on number 24. I've got x, 3 to the x, 3 to the y, 4 to the x. So which ones can I put together? Is that right? Is it the 3x and the 4x I can put together, or the 3x and the 3y? Nope. It's the 3x and the 3y. The bases have to be the same to put them together. Just like up here, like I can't put an A with a B, right? We were pretty good on that. That made sense. But it's weird whenever it's numbers instead. But I can't put a 3 with a 4, right? Because those bases are different. So this would be 3x plus y times 4 to the x. And you just wouldn't be able to put the 4 with the 3. You'd have to stop there. So the bases have to be the same, not necessarily the exponents, to add those together. Yeah. Yeah, 3 to the x plus y. All right. Okay, I think I'm actually going to have you guys do a worksheet. We might save the Delta Math for the morning tomorrow. We're going to get both, but we don't have time. Not enough time. Although, if you finish this worksheet, because the thing about these problems is that, like, if you know your rules really well, you can do these problems really fast. They don't, and we did 24 problems on the practice, and it didn't take us all that long. Here. So, if you do finish this in class, go work on your Delta Math for a minute until class is up. But the Delta Math will not be homework. I will move it